Now let's move into cyclic quadrilaterals. What are cyclic quadrilaterals? A cyclic quadrilateral is just a special kind of shape that has 4 corners, and all 4 of those corners touch or lie in the circle's circumference. In simpler terms, all points of the shape are on the circle's edge. So here we could see a quadrilateral inside the circle, right? So we have a circle and we have a quadrilateral, whether be it anything inside the circle where all 4 vertex are touching the circle's edge, right? Now these kind of quadrilaterals are called a cyclic quadrilateral. 4 points on the circle. First you draw a circle, then pick any 4 points as the edge. Those points would be the corner of a cyclic quadrilateral, right? Now it's connected by lines. So we took a circle. We chose 4 points on the circle, let's say these 4 points, and I'm connecting them. So I connected them, right? Now this is a cyclic quadrilateral, right? It will look like a 4-sided figure inside the circle, just like all these. The thing about cyclic quadrilateral is that if you add up the opposite angles, they will always be equal to 180 degrees. So why is it? Because let's say this is a circle, right? So this angle and this angle should be linear. That is, they should add up to 180 degrees, right? And if I am adding this angle and this angle, we would again get 180 degrees, right? This is one important property of cyclic quadrilateral. Now let's see some interesting things which is very much used in solving questions from circles. Now first of all, circumference of a circle. The circumference of a circle is the distance around the outside edge. So if this is a circle, circumference of a circle, also called as the perimeter of the circle. The perimeter of the circle is calculated by 2 into pi into r. So what is pi here? Pi is actually a value which is approximately equal to 3.14. The values goes on after 3.14, but it can also be written as 22/7. It's a constant. If you have to find the perimeter of the circle, you have to find 2 into pi into that radius. Now, what about the area enclosed by the circle? The area enclosed by the circle is equal to pi into the square of radius. Now, chord. We talked about chord. Chord is a line segment connecting 2 points in the circle's circumference. So, if this is a circle, this line is called a chord. Now, diameter. The diameter is a chord that passes through the center of the circle, right? Dividing the circle it into 2 equal halves. What is the diameter of a circle? So basically, diameter of a circle is the chord. Chord means a line which is connecting 2 different parts of the edges, which passes through the center. If I'm connecting these 2 things, it's passing through the center. This line is called the diameter of the circle. And what does it do? It gives us 2 radius. What is diameter? Diameter is 2 times radius, right? Now, secant. Secant is a line that intersects a circle with 2 distinct points, right? If a line is intersecting the circle with 2 distinct points, if I say there's a line intersecting the circle with 2 distinct points, this is called a secant. Now, tangent. Tangent is a line that touches the circle at one point, called as the point of tangency. So, what does tangents do? Let's say there is a line, this is called the secant, right? Now, a tangent is the line touches the circle at exactly one point. This point is called the point of tangency. Now, this is called a tangent. This line is called the tangent. A tangent could be drawn anywhere, right? It's touching just one point of the circle. It could be drawn anywhere. Now, arc. Arc is a part of the circle's circumference between 2 points. So, this could be an arc, right? We could say that this is an arc. Now, this could be an arc, right? So, this is about arc. Now, central angle. The central angle is an angle whose vertex is at the center of the circle and its 2 sides are 2 vertices. So for central angles, we have, the center to be this point, and then we take 2 radius, and the angle formed in between this is called the central angle. Now inscribed angle. Inscribed angle is an angle whose vertex is on the circle and the side intersect the circle at 2 distinct points. So these are some important things about circles. So let's move on to visualizing solid figures. So what is this object? It's a 3D object, right? We don't know the particular shape of the object. It's cylindrical, but then there's a cone on top, right? But what are these cylinders and cones? Just as we studied about squares, rectangles, circles and all, these are 2-dimensional figures. What does 1-dimensional and 2-dimensional mean? 1-dimensional means it just have 1 dimension. That is, if I'm saying a line is moving like this, right? This is 1-dimensional. Why? Because it only moves in one direction. It just have one coordinate which is moving. For example, imagine an ant which is moving on a straight line. It's not changing direction, but it's just moving in a straight line. See, that is, the ant is traveling in a 1-dimensional motion right now. Why? Because there is no other coordinates required to explain the motion, right? We just use the x coordinate or y coordinate or any one coordinate to say that it's moving in one direction. So that is called any object which is in one dimension or which could be explained with one coordinate is called 1-dimensional figures. Now what are 2-dimensional figures? 2-dimensional figures needs 2 coordinates to explain them. Very simple. So we have x-axis, we have y-axis, right? Imagine this board. This board is actually a 2-dimensional figure. It's in a rectangular shape, right? We have x-axis and y-axis. Any point in this board can be explained by using a distance from the x-axis and distance from the y-axis, right? I could spot any point on this board saying that I'm saying that it's around 16 centimeter away from the x-axis. If I'm considering this as origin, it's 16 centimeter from the x-axis and 15 centimeter from the y-axis. I could exactly describe the position of a point using 2 coordinates in 2-dimensional figures. So when we are talking about square, right, we could explain that point by using 2 coordinates. Like if I'm taking an xy coordinate here, right, or xy anywhere, we could just locate every part, right? Now rectangle, this circle, everything applies the same. Now what are we talking about when we actually consider a square or a cube? Sorry, what are we talking about when we say a cube? We all have seen Rubik's cubes, right? So Rubik's cube is an object. It's not square, but its face is a square, right? So any object around us we see is a 3-dimensional object. That means for 3-dimensional objects, we need 3 coordinates to describe them. That is, there would be a z-axis. It would be x, this would be y, and there is a z-axis which would explain to us what is the position of the object. Like if I'm holding this stylus here in the air, there would be an x distance. What is x distance? Let me say the x distance is the distance from my origin on the floor to here. Now I'm holding it at a height, right? So what is the y distance? The y distance would cover this. Now what is the z distance? We live in a 3-dimensional world, right? We live in a world which we see objects in 3 dimension, right? So everything which could be explained by 3 dimensions, we could actually look at the corner of the room, right? Go into a room, go to the corner, we'll see 3 axes at the corner of the room. The x-axis, let's say y-axis, and the z-axis, which tells us how far is the object from us, right? So this is a particular special thing about 3-dimensional objects. Now let's visualize some of the solid figures. Now polyhedron. Imagine you have a bunch of flat shapes like a triangle, square, rectangle and pentagons. Now take these flat shapes and put them together to create a 3-dimensional object like a box or a ball. Well, that 3-dimensional object you make is called a polyhedron. Just like we say that the square, rectangle, everything is a polygon, right? All these figures which are made up, let's see, I'm putting a square here. I'm placing another square on top of it, I'm placing another square on top of it. Like that, I'm placing a lot of squares and I'm creating a three-dimensional object with a little bit of height, right? The concept of length and breadth change into length and breadth and height, or the depth, right? Just we talked about area for two-dimensional object, it changes into the volume when it comes to three-dimensional object. Why? Because area is basically the thing we see on the surface. If this is a triangle, the surface would have area, right? We could say the area of a three-dimensional object, but in order to exactly say what a three-dimensional object is, we need to find the capacity or the volume of that object, right? So when we are talking about putting together a lot of squares, a lot of rectangles and everything, we find three-dimensional figures, and these three-dimensional figures which are obtained like this are called polyhedrons. A polyhedron is a solid shape that have flat faces, edges and corners. Just like here, this is a very complex polyhedron right here, right? But this have a pentagon face. One of their faces is a pentagon, 2, 3, 4, 5. This face is a triangle, right? Now this face is 1, 2, 3, 4, another pentagon. Now this is a triangle. So this is a mixture of pentagons and triangles, right? So a polyhedron would have flat faces, then we have edges for this. Now when we are taking a cube and holding it on our hands, we'll see a square face and the edges of it, right? And it would have corners, right? The faces are the flat sides of the shape, like the wall of the room. The edges are the lines where two faces meet. So this is a very important point which is given here. The edges are the lines where two faces meet, and the corners are the points where three or more edges come together. Let's see. These are the edges, right? What are the edges? Edges are the lines where two faces, this face and this face, meet at this edges, right? And the corners are the points where three or more edges come together. We have two edges here. This is the third edge. This would be the fourth edge which is behind it. Now that comes together at a vertex. Again, same here, we have 1, 2, 3, 4 edges coming together, right? Now these are the vertex, faces and edges of a polyhedron. Now let's study about some different types of polyhedrons. First of all is a cuboid. So cuboid is the solid version or the three-dimensional version of a rectangle, right? So we are taking a rectangle, right? So this is a very easy way to draw it. We took two rectangles and I'm joining all the corners of them, right? Now the shape we got here is called a cuboid. Let's say we have a book over here, right? Let's consider a book, and a book would be of a cuboid shape. How? See, this have a length, it have a breadth, and there is one more quantity which should be required to define this book, right? Now a face of this would be a rectangle, right? A face of this would be a rectangle. Now let's see, it have a cuboid, it's a 3D shape with 6 faces. So how do we count the faces? We have one face here, second face here, third face here, fourth face here, fifth face on the upper side and sixth face on the lower side. Let's take a matchbox as an example. It's a very beautiful example of a cuboid, right? So if we are taking a matchbox, how many faces can you see? It would be 1, 2, 3, 4 up and down, and the ones on the sides, that is 4 and 5 and 6, right? Now let's talk about the sides of the cuboid. We have 3 pairs of equal sized sides. The length, width and height of these 3 measurements of those sides. So we have 3 sides of the same, right? You can use the formula to find the volume of a cuboid. So just like we taught about, we have area of a rectangle, right? We could find the area of this face, we could find the area of this face, area of this face, area of this face. Every face we could find the area of them. Now what about the volume? What is volume? Volume is the capacity of that figure to hold something, right? Let's say that I'm taking a cuboid and I'm filling water into it. So what is the amount of water that can fit into the cuboid? That the volume of the cuboid would determine that, right? The amount of water which I could fit into a small figure and the amount of water which I can fit into a larger figure are both different, right? So what is the formula to find the volume of this figure? The volume of a cuboid is equal to the length, which is given here, length into the breadth or height, any depth, you could say anything, breadth or depth, right? And this is the height. Length into breadth into height gives the volume. Now, let's talk about cubes. See, this is a cube. So, we told that the cuboid is the three-dimensional version of a rectangle. Now, what is a cube? A cube is the three-dimensional version of a square. So, if we are taking a square, right, we are changing it into a three-dimensional object, right? All the edges are gone, right? Now this is a cube. We could find a very neater version of cube here. Then a cube is a special three-dimensional shape that you have seen in your daily life. It's like a box, but all the sides are of the same length and all the angles are 90 degree. So what is the speciality of the cube? All the angles in a cube at all the corners would be 90 degrees. Just like cuboid also have 90 degree angles everywhere, right? Now, a cube have 6 flat faces. We call them sides or faces. So, just like cuboids, we have 6 faces for a cube. Take a Rubik's cube and count the number of faces it have. It has 6 faces. Now, these sides are all the squares of the same size. So, what does a cube consist of? It consists of 6 faces with the same size. Now let's look into some terms which we have about cubes. So edges, the lines where two sides meet are called edges. We talked about edges when we are talking about cuboids. So when two faces meet at a point, at a line, that is called the edge of the figure. So for a cube there are 12 edges. Now vertices, the point vertices is the plural form of vertex, right? Now the points where 3 edges meet are called a vertex. So we have 1 edge, 2 edge and 3 edge. This meet at a point, it's called a vertex, right? A cube have 8 vertex. How does it happen? So let's say this is a cube, right? This is a cube. It mostly look like a cuboid, but still let's say that it's closer. Okay, now it looks like a cube, I hope. Now let's say that we have one vertex here, second, third, fourth, and the same goes to the bottom, 5, 6, 7 and 8. So we have 8 vertex. Symmetry. Cubes are very symmetrical, right? This means that if you look at a cube from different angles, it will look the same. Each side can match another side by rotating or flipping the cube. Like any side of the cube would look the same, right? Because it's basically the same size. Every edge have the same length, right? Now, dimensions. A cube have 3 dimensions, length, width and height. But because all sides are equal, we only need to know the length of one side to describe the cube, right? Now, volume. Volume of a cube is measured of how much space it takes up, just we described before. To find the volume of a cube, you just need to multiply the length of one side by itself twice. That is, here we know that in the case of cuboid, we had different length, breadth and height. So we were multiplying length and breadth and height for to find the volume. For here, length and breadth and height are equal. So everything is length. So this becomes L cube. L cube is the volume. Now surface area. The surface area is the total area of the sides of the cube. So what is the surface area? If I am taking a book like this, the whole area which is covered on all the sides of the books is called the surface area, right? The surface area is the total area of the sides of the cube. To find the surface area of the cube, you need to multiply the length of one side by itself and then multiply the result by 6. So for one square, the surface area would be a square, right? If this side length is a, this would be area would be a square. Now if we take 6 sides, we have 6a square to be the total surface area of the square. Now let's move on to the next very beautiful shape, which is a cylinder. We are well known with cylinders, right? The very best example for cylinders is the Pringles we eat, the container of Pringles, the chips we eat. It's a very beautiful looking cylinder. So what is a cylinder? We said that the cube is the three-dimensional version of a circle, no, a square. A cuboid is a three-dimensional version of a rectangle. Now, cylinder is a three-dimensional version where a circle is kept and we are elongating the circle, right? A circle is kept at the base and we are dragging the circle up, right? Now, we get a long shape where both the sides are circles, right? Now, these are called a cylinder. Now, let's move on to what is a cone. A cone is a 3D shape that looks like a circle at the bottom. It's just like the base of your ice cream cone. We all have seen ice cream cones, right? It just looks like this, right? It just looks like this. Now, this is a cone. This shape here is a cone. So, what does it have at the base? So, let's say that on the back side we have this. So, this is called the base. So, base is a circle and the perimeter of the circle, right? So, we have a circle from here. So, this is the circle, right? Every point from the edge of the circle is connected to one point, right? To one point, I am connecting every point from the circle. Then I will get a 3D shape called the cone, right? So, it's a triangle stretched out and turned upside down. It's a very funny way to explain this, right? Now, sphere. So, what is a sphere? We always thought that, the earth is a spherical object, right? So, a sphere is a three-dimensional version of a circle, a total three-dimensional version. We see balls all around, right? Like a football or something, right? This shape is called a sphere. A sphere in geometry is just like the ball. It's a three-dimensional shape that is perfectly round in every direction. If you look at it from any angle, it will appear as a perfect circle, right? Shape. A sphere is a perfectly symmetrical 3D shape. It have no corners, no edges or flat surface. It's like rounded, right? It's smooth and continuous all around. Surface. The outer layer of a sphere is called the surface, right? If you touch a ball, you are touching its surface. So, what is the surface? In this case of a cube, we have said that around 6 faces of a cube, right? Just like all the corners, all the vertex of the polygons, turns out to be a circle. Just like this, we are transforming it into a 3D thing. We have a cube. Then we have like, whatever this is, we connect it, right? We get a 3D shape. Now, what is the n number of vertex converted into? It's converted into a sphere, right? Now, center. Imagine a tiny point right at the center of the ball. That point is the center of the sphere. Every point on the surface of the sphere is in the same direction from the center. So, to explain this, imagine this is a sphere. The sphere would have this much radius and this much radius, right? So, in that, if every point, let's say that we are cutting a ball, finding the center of it, right, and rejoining the ball. Now, we know where is the center of the sphere, right? Now, the radius, the distance from the center of the sphere to any point on the surface is called the radius. If you have a cricket ball, the distance from the center to any point on its surface is the radius, right? Now, it's like drawing a straight line across the ball through its center. Now, the volume. Spheres have special property that help us calculate how much space they can hold inside. This space is called volume. So, what is the capacity of the sphere? If I'm taking a ball or a balloon, which turns out to be a spherical balloon, right? If I'm filling up air inside the balloon, how much air could be filled inside this balloon, right? So, that is the maximum volume of the sphere, right? The formula to find the volume of a sphere is 4 by 3 pi into radius cube, right? Now, hemisphere. So, what are hemispheres? Hemisphere is made up of two parts. The word, right? Hemi, which means half, and sphere, which means a sphere or a ball, right? So, when we say hemisphere, we are talking about half of the sphere, right? We had a sphere, we just cut it into two parts, right? This is the 3D. So, we cut it into two parts. So, the upper part, the 3D version of a semicircle, right, could be said as hemisphere, or the lower part. Any one of the part could be called as a hemisphere, right? Now, hemisphere would have a radius, right? What would be the area of the hemisphere? It would be half times the area of the sphere, right? the last thing we are talking about in this chapter is about pyramids. So what about pyramids? Have you seen pyramids in like movies and all, in the Egyptian things? Egyptians have built a lot of pyramids which looks very pretty, just like this. So what is a pyramid? A pyramid in geometry is a solid three-dimensional shape with base and triangular sides that meet at the point on top. So we could say different types of pyramids. The most common one is the square pyramid, right? So we have a square here, we have a point here. Then we join every face, every vertex to the vertex of the point, right? Now this is a square pyramid, right? Now we say that, let's say there is a rectangle, right? This is a rectangle and we have a point here. We are joining every points, every vertex to this one point which is there, right? Now this is a rectangular pyramid. We could make pyramids out of any shapes as a base, that doesn't matter, right? So basically pyramids are three-dimensional objects where, you know, every side would join into a triangular shape and then go to a point, right? Now this is called the apex of the pyramid. You could call it the apex, and this is the base of the pyramid, right? Now there is an interesting fact that, you know, if we are taking the circle as the base of the pyramid and we are saying there's a point here, what is the shape we are getting? We get a cone. So cone could be said as a special type of a pyramid, right? Now this is all about the chapter quadrilateral. So what all did we talk about? Let's move on and just let's think about it. So first of all, we discussed about what are the different types of quadrilaterals. We talked about what are parallelograms, which are slanted rectangles. Now we talked about what are rhombus. We said that it's a little bit slanted square. Now rectangles, all 90-degree angles, length and breadth are there. Now trapezium have two parallel lines and two non-parallel lines, right? Now a kite is a special diamond shaped object. Then we talked about the properties of kite. Then we talked about circles. Circles have n vertex, right? That is the maximum number of vertex we can have. It have a specific radius and diameter. Now arc of a circle is like a part of the circle's edge. Arc can be measured in degrees. Now chord of a circle is a chord is a line which joins two points on the perimeter of the circle, or on the circumference of the circle. If we join two lines, we get a chord. Now we talked about a different type of chord, which is a diameter. Diameter would pass through the center. Diameter would pass through the center of the circle. Now secant is a line which starts from the center of the circle and go through circle's edges, right? Now semicircle is the half of the circle. We talked about the property of angle of a semicircle. Then segment is the part of the circle. Now central angle is the angle subtended by one line and any other line or in reference to this line. So when we say that the central angle is small, the part which is covered is very small. If we say that the central angle is huge, the part which it covers is very huge. Now, then we talked about sector. Sector of a circle is a part of the circle that is formed by two straight lines starting from the center of the circle and going to the edge, right? Now, we talked about four quadrants in the circle. So the first quadrant where x and y are positive, second quadrant where x is negative and y is positive, third quadrant where x and y both are negative, and fourth quadrant where x is positive and y is negative. Now we talked about cyclic quadrilateral. Cyclic quadrilaterals are the shape when we take a circle, we put 4 points on it, we connect them, and the figure we get is called a cyclic quadrilateral. Now circumference of a circle, we talked about some important formula about the circle, like area is equal to pi r square and perimeter is equal to 2 pi r. Now we talked about three-dimensional objects and we talked about what are polyhedrons and what is a cuboid, a cube, cylinder, cone and sphere and hemisphere and pyramids, right? So this is all about the chapter quadrilateral.